Hi everyone, welcome to today's webinar based on CoreOS Tectonic, how to easily run Kubernetes Enterprise-Readiness on AWS. This is hosted jointly by Amazon Web Services and CoreOS. My name is Omar Lari. I'm a solutions architect on our partner team. I will be your host, speaker, and moderator for today's webinar. When you join the call today, you chose to either join by phone or your computer audio. In the event you lose your audio connection or you decide you'd like to change for any reason, you can do that by accessing the audio pane in the webinar controller on the panel on the right. From that same control panel, you also have the opportunity to submit any questions to today's presenters. We'll collect your questions and address them during the Q&A session towards the end of the presentation. This is going to be a great opportunity for us to address any of the questions that may not have gotten answered during the presentation. And I'll also just provide a rich and enriching experience for the rest of the attendees. So please do submit your thoughts and help us answer your questions. After the webinar, the presentation deck will be available through SlideShare, and we'll post the full video on our AWS YouTube site. An email with links to all of that will be sent out in the next few days after the presentation. So go ahead and just keep an eye out for that. So a rough agenda of what we're going to talk about today. Basically just the topics that are displayed here. It's really talking about what are containers, what are the benefits that they can bring to your organization, and how you can leverage CoreOS to help you run those container workloads on top of AWS. So a lot of industry shifts that we're seeing today and cloud computing that are also applicable to containers. Some of the main ones here listed: elasticity. Basically, this means that you can scale up and scale down to what your compute needs are, what your users are demanding, and pay for only the resources that you actually leverage. So there's no waste, and you have exactly the amount of resources that you need to run your workloads and provide your services to your customers. Agility is really just about the ability to iterate quickly, move your application between different environments quickly, and just be able to display, provide new functionality and features to your customers at a lot faster pace than we've been able to do in the past. And lastly, high availability, the ability for you to deploy your application and your infrastructure into multiple availability zones, multiple data centers across multiple regions, the ability for your applications to really self-heal in the event that there's any problems with either the infrastructure or the code. And just providing a really high availability experience for your customers and end users. So containers kind of build on a lot of those principles. Basically what containers are is they're a way of allocating resources to processes and running those processes in isolation from other containers. Talk a little bit more in detail about this later in the presentation. But basically containers, they each have their own code, runtime tools, and libraries. And then they share a host operating system and a kernel with other containers. This allows many containers to run on a single operating system. And since everything's packaged together, it also allows for portability of that container into multiple environments. So in addition to some of the benefits that we have listed here, you also are allowed to use the same infrastructure without causing conflicts, since all of your code and dependencies are packaged up independently. Another really important benefit that's not listed here is that they're extremely lightweight, which makes them easy to move, share, and instantiate on new environments. So what does this mean for you? Like I said, building on some of those cloud principles, some of the additional things that it does is that you really use software-defined and immutable infrastructure, which means that any changes to your application or infrastructure need to be committed to source code repository. This helps with automation of your environment. As your application moves from development to production, you know that what you're running in dev on your laptop is the exact same as what you're running in production. So some of the benefits of running containers in AWS, the first one we've got listed here is the integration into all of the other AWS services. So you have access to the full spectrum of AWS services that we have available to help you build your microservice container applications. So we have services like DynamoDB for NoSQL databases, RDS for relational databases, SQS for queues, some automation tools like CloudFormation, monitoring tools with CloudWatch. You can analyze and look at what those logs are doing with Elasticsearch. There's many other additional services that we have across compute, networking, analytics, mobile to help customers be more productive. We continue to add more features and functionality at a rather accelerating pace. In 2011, we had 80 significant services and features released. In 2012, that was nearly 160. And last year, we launched 1,017 new services and features. So there's always these new features and functionality that are coming out that customers have the ability to leverage and use in their container environments. There's a global footprint. As of today, there's 43 availability zones across 16 geographic locations worldwide. Additional 3 AWS regions are expected to come online throughout 2017 and 2018 in France, China, and Sweden. So this really allows you to go global in minutes and deploy your infrastructure globally. Next is security. AWS has achieved a number of internationally recognized certifications and accreditations, enabling customers to achieve their specific security and regulatory objectives. There's tools like CloudTrail, KMS, and Inspector that all help customers meet those objectives. And then finally, which we're going to talk about today, is the partner ecosystem. So we have a rapidly growing partner ecosystem that provides customers to meet any specific objectives and extend services that are provided within AWS. Tools that they may be accustomed to already using in their data centers can also be used, and our partner ecosystem really enables that. This is a kind of a landscape of what the partner ecosystem looks like today in the container space. In the middle blue box there, you kind of see the foundation partners. So these are partners that will help you run containers in a distributed cluster environment, so provide the orchestration, management, and scheduling of those containers in complex clustered environments and help make that easier for you to run. And then in the top blue box, we have ecosystem partners that can provide additional capabilities around network, security, continuous integration, deployment to help you move your containers in a secure fashion from development environments into production. And so the partner that we're going to talk about today lands in that foundation space, CoreOS. CoreOS extends the upstream Kubernetes open source project to make it a little bit more approachable for enterprise organizations to adopt into their environments and run an open source project in a supported manner. It integrates with a lot of our AWS constructs, things like auto scaling, elastic box storage, and load balancers to provide those additional functionality into your container workloads. And with that, I'm going to go ahead and pass it along to Rob from CoreOS, which will talk about the Tectonic product.
Hi there, everyone. Thanks for joining us today. So I'm a product manager at CoreOS. I handle our enterprise container platform, Tectonic, which we're going to talk about today. So we're going to talk about some of the features of Tectonic and how it fits into the greater AWS ecosystem and kind of what you get for your developers and engineers out of it. And then we'll take a quick demo through our console and talk through some of the way that Tectonic is set up. So I want to briefly step back and dive a little bit deeper into some of the benefits of containers that Omar talked about. And what it really comes down to is that we've had these traditional monolithic architectures that end up looking like something you see on the diagram on the right. They're very hardware-centric. You know, you're touching the IT organization to rack servers. You know, there's a high amount of technical debt. And then all this infrastructure that you are developing and debugging, and even down to like cabling and that type of stuff, is not really applicable between stacks. So you make these infrastructure silos. So you've got your platform as a service product that you might be running. You've got some infrastructure as a service, and none of it's really integrated together. You can't share capacity when something has slack resource usage, and it's just very much not flexible. It's not agile. And so this is why we're here with containers and following along the footsteps of a lot of folks that have been innovating in containers for a long time, most notably Google and their open source efforts to get these features up into the Linux kernel, and such that we can now all take advantage of them. So we talked kind of high-level benefits of a container, but when it comes down to it, the really cool thing is that you are not instantiating an entire guest operating system inside the VM. Yes, you do have some of the internals of a Linux distro and its user space inside of a container, But if you're really doing containers right, you can actually get this down to, you're just inserting single binaries or these very much custom-built environments instead of just saying like in a Docker file like from Ubuntu or Debian, building something. But even if you're doing that, what you get is an immutable image. So you can store this artifact of your application and its dependencies versioned in a registry, and then you have an image that you can always deploy out that is working correctly. And then if there is a known bug or vulnerability in it, you can then audit what's actually running across a cluster or a set of VMs to know what needs to be changed and kind of alert your security team, that type of stuff. And this is great for incidents, but also just kind of the general just what is running on my infrastructure that a good sysadmin is doing. So let's dig a bit into the value of the container, and it's really just you're extracting away your application from the OS such that you can then move it around a cluster. Now you don't really care exactly where this operating system is running. You care that it has an up-to-date kernel and that type of thing, but you don't care which version of Python is on the host, or even if it has Python on the host. CoreOS Container Linux does actually not ship a Python interpreter on the host, nor do we ship a lot of kind of common tools that you see in these regular distros. And that's because it's container focused, and all those dependencies should be in your application, so you can bring in your version of Ruby and your source code, etc. And so what that looks like versus a traditional distro, on the left you see that you ship in, say, Red Hat Enterprise Linux, you'd have Python and Java and Nginx, and there's an OpenStack install in there, and there's all kinds of stuff in these distros. And what we've done with Container Linux is strip all that out and move it into containers. So this takes the immutable infrastructure one step further in the right direction. Containers are the first step. Running on a container-focused operating system is the second step. And then third is having a container-focused orchestration system and CI pipeline. What this gets is a much smaller attack surface for the VMs that you have running on the internet. So you really just have the essentials to really start your container runtime, do some logging, have an SSH daemon running, but everything else is done in containers. And then you can further certify which container is allowed to run on which hosts, and we get into orchestration systems for that. So what this really gets you is increased productivity. You're not spending time debugging which version of Python is on this host, or did somebody run either a chef run that I wasn't aware of, or somebody manually SSH'd in and did a package upgrade and broke all the applications running on this VM. What you're doing is running standardized tests against code when the container is built, and then you have this deployable that is known to be good. In addition to the kind of developer side of it, on the infrastructure side, if you're an IT owner, now you're not spending money running VMs, bare metal servers, whatever it is, that aren't fully utilizing their CPU or RAM. And so you can actually kind of, what's known as bin packing, stuff more applications on each host. And then the benefits of containers, you're not stepping on each other's applications. And a lot of orchestration systems, you don't even know that these other applications are running on the host by design. And then what that gets you is the applications that can be deployed to any host as a container, and then that means you can start being fully cloud agnostic. You can start doing hybrid workloads, running between different regions on a cloud provider, and your applications might have to minorly be aware of that, but in terms of what's in the container itself, it is not tied to any host or cloud. There's been a lot of research out there in container adoption. I just wanted to share one interesting step in that research, which is on the left, you see the usage of containers, folks that are just starting to do some evaluations, then getting their initial applications in production, and then kind of the broad organization-wide adoption of containers. And the really interesting thing about this is use of containers and use of orchestration software are basically one-to-one. And this is kind of a no-brainer. It really makes sense. One node and running one container or two containers is interesting and useful, but it gets really interesting when you're running 300, 1,000 nodes, and then having thousands of applications running on top of that. So you're getting that bin packing, you're getting the best resource usage, and that really requires orchestration software. So let's dig a little bit more into Tectonic, which is CoreOS's kind of enterprise-ready distribution of Kubernetes. And In addition to all the benefits we just talked about, you're getting all the automation features built into the Kubernetes API. This is things that hook directly up into a CI system, doing rolling updates, secret management, configuration management, as well as all of the kind of user-facing side of the house with role-based access control, locking down different teams to different sets of resources. It's all built into Tectonic. And this really lets you have a lot of teams sharing standardized cluster infrastructure to get better utilization. And the best part of it is you get the best version of Kubernetes. We have a feature that we call automated operations. And this is the ability to get unmodified upstream Kubernetes, the latest version, install that, keep it up to date with a one-click automatic update. It's in place, zero downtime. It works just like a cloud service, but you can consume it on any infrastructure provider you would like. And that's really important because all of your developers are going to be wanting to use new versions of the Kubernetes API. It's getting better and better. It's more stable, as well as having different primitives for doing things like cron jobs or one-off jobs and stateful resources and that type of thing. So getting that 100% upstream Kubernetes is really important, such that your consumers of the API can then use those features. So Tectonic builds enterprise-ready features around that upstream core unmodified Kubernetes, and that's things like governance services to meet all of your security needs and making sure admins can know what's running on the cluster and that folks have the correct permissions. Full stack monitoring of the cluster itself, as well as applications running on top of the cluster. A portability layer, which is kind of where you can run on multiple different providers, do hybrid cloud, that type of thing, across different regions in Amazon, for example, and the cluster operates the exact same. And then the automated operations engine that I was talking about, this is what allows you to do in-place, no downtime upgrades of Kubernetes at any time you would like. We're constantly shipping new updates out, and this updates not just Kubernetes itself, but all of the Tectonic components as well. So you're getting security enhancements, performance enhancements of our console, all the software that we ship, including our governance services connecting out to like LDAP and that type of infrastructure, as well as the full monitoring stack and kind of everything that's included. And that's really important because you can't just upgrade the base. You've got to have full coverage in order to really keep your cluster secure. I wanted to talk about two customers of ours, Ticketmaster and Concur, who've had very successful experiences with Tectonic, but they've seen some intangible benefits that I think are really interesting. For Ticketmaster, they had a mandate to move all of their infrastructure to the cloud. They have several older bare metal style data centers, as well as some here and there Amazon deployments, and they needed to standardize all of that to get better efficiency, and they chose Tectonic as the platform to do that. And this is a quote that they've shared with us, and they've really seen all of their engineering teams reduce technical debt when everyone is running containers. This means the organization is sharing standard debugging practices, performance optimizations, build pipelines across different engineering teams, maintaining different base images for their use. And this is where they see drastic technical debt get reduced as they're also consolidating all of these data centers down onto Amazon. And then Concur, not on the technical side, but more on the kind of organizational culture side, has seen containerization and Tectonic really energize their teams. And their teams are really excited about the engineer experience of building containers, have applications rolled out and started in milliseconds. They're not fighting against their tooling. They're getting to use new stuff, and it's really empowered them and energized them to really ship new features. And so we think these two sides of it are equally as important, tackling the technical side as well as the organizational side and the inertia of, oh, I've got to learn this whole new thing, and this is all bleeding edge, and it's a little bit different than what I'm used to. But you get that excitement again, as well as all the great benefits of containers. I talked about the portability layer. This is the ability to run across a number of infrastructure providers. This is core to Tectonic. We want your Kubernetes cluster to feel the exact same no matter what infrastructure provider you're running on, because just like containers abstract you away from the host, If your applications are now deeply tied into one of these infrastructure providers, it can be harder to move those around, as well as doing like local development and then production on Amazon, for example. So we provide tooling and installers for all these platforms to get up and running, such that those infrastructures look very similar. On the automated operations, we talked a lot about the painless patching, but this also is the engine for doing failover and high availability of the entire cluster. I'll talk about this when we get into monitoring, but Kubernetes is actually so great at high availability, you actually need some monitoring to even know that the control plane is experiencing failures because other parts of the system are taking over, which is a really good sign to have. And the last bit built into automated operations engine is the ability to do automated cluster deployment. All of our installers are powered by Terraform, such that you can do the infrastructure as code, you can check these into your source control, and then we have a lot of customers that aren't just running, one cluster, two clusters, but it's 10, 12, 15, depending on regions and different regulatory needs that they have. And so a lot of them choose to then hook up cluster deployment to a CI pipeline, just like you would an application. So you can boot up new VPCs and then programmatically install applications to it for kind of testing environments, and then have a long-lived production environment that sticks around for a long time. And because the way that we set up the infrastructure is really important, I wanted to walk through what a typical VPC layout looks like on Amazon. So we have some private Route 53 domains, pulling some assets from an S3 bucket, and all of this is set up by Terraform. And you've got two auto-scaling groups, a master and a worker auto-scaling group. And all of these we're showing in a public subnet. We'll look at what some private ones look like on the master side. And then the auto-scaling group for the workers is only talking to that master through a private interface, keeping all of your workers off the public internet. And Tectonic has facilities for exposing different routes out to the internet via the Kubernetes ingress. And then what this looks like in terms of how the nodes are set up in Kubernetes, everything is labeled such that you can target different worker and master roles, and regions are auto-populated, as well as the size of the machines if you want to target those workloads with your containers. This is really important just to get that consistent install out of the default, such that you can always count on these labels being there. And what we do is we actually run the Kubernetes infrastructure to run the cluster on these master nodes with Kubernetes. And I'm going to show this in the demo of what that looks like. And that's where this role master becomes very important. And what this looks like when you're actually running all of that software is across the 3 or 5 or 7 masters that you have running, we're going to run an HA copy of the Kubernetes scheduler, an HA etcd cluster, HA API, controller manager, etc. And all these are critical to the functioning of the cluster itself. And then the workers run the Kubernetes agent, which is called a kubelet, and that is how all of your containers will get started on those workers. And those can consume EBS volumes, and if you want to expose one of those out, you can programmatically make ELBs and that type of stuff, as well as talk to any other Amazon infrastructure that you'd like. So this is what that looks like when you use kubectl, which is the Kubernetes command line utility from, say, your laptop, you're a developer. You go in and talk to the API server through the VPC's public ELB. Now, if you want to have a private cluster, what you would do is we would switch all those public subnets to private. The private ELB is turned from public, and then what you would do is talk to this cluster through a VPN. This is a very popular method to do it. You can use Bastion hosts and that type of thing as well to keep all of your infrastructure offline. And then equally important, if you're running your private ELB, you can also install it into an existing VPC versus creating a new one, such that you can talk to existing, say, RDS databases that you have, another backend that's running on either another cluster or just raw EC2 VMs, such that you can, port over some applications, say like your front end, and then talk to the back end on your existing infrastructure over time. This gives you a lot of flexibility as to how you want to roll out your cluster. And then, most importantly, if you have a private data center that's connected via direct connect, then you can also talk to those resources as well. So this is what you would do in like the Ticketmaster type scenario where you've got some private data centers, you peer them into Amazon, and then roll out your services there. You might decide that you have some services that should never get migrated to the public cloud for organizational reasons, performance, whatever it might be, and you can talk to those through Tectonic. One really important part of Tectonic is that we integrate into the cloud provider very deeply via the Kubernetes cloud provider code base. And what this does is let you utilize Amazon resources automatically. So you have a service in Kubernetes that you'd like to expose publicly. You can say this service is of type load balancer. It will automatically create a load balancer for you, wire it up via the security group and do all of that for you, and then have that routed directly into your application containers. The same thing works for EBS volumes. So you say, I would like to mount a stateful volume onto this container. It will create the EBS volume for you, mount it to the node where that container is running. If that container gets rescheduled, move the EBS volume for you. It just works like magic. It's really great. And then you can use our console to control different settings for all of that stuff via Kubernetes annotations. I talked about our install using Terraform. I want to briefly touch more on the benefits of this because this is a super powerful part of Tectonic, such that you can templatize your cluster deployments. So if a lot of folks choose to have, staging, QA environment, and production, for example, and what you can do is using Terraform, use the exact same settings to bring up each of those environments, so you're truly getting that immutable infrastructure, but just, say, give it a different name, possibly a different region, and then some different like TLS secrets, for example. And this is really, really great for setting up those consistent environments, as well as providing a self-service way for your development teams to set up environments as they may want to do separate load testing without impacting everybody else. They can use that same set of config to boot a new temporary cluster in a region, for example. And what our engineers have done is get you the best practices for using Terraform and its kind of module setup and that type of thing, as well as the best Kubernetes configuration. We are constantly integrated with the upstream community and setting all the correct flags and setting up things in an HA manner, making sure TLS is used between all components for communication, that type of stuff. So you really get the best of Kubernetes as it's released. We're updating our installer constantly. And then if you have running clusters through the automated operations, you can update those in place as well. For application owners, we talked a lot about infrastructure. Shifting up, in our governance services, you have the ability to tie into a lot of your infrastructure that already exists. So LDAP servers, if you have groups defined for your different engineering teams, you can hook into those for access control in Kubernetes. That is a really great way to say, Kubernetes has a concept of a namespace, which is really just a group of resources. And so you can have a namespace for all of your development teams, for example, and or per employee that you have, and have different dev environments in there, staging, QA, integration environments, all controlled and accessed through role-based access control, such that you might have a contractor, for example, that you want to grant access to certain production resources, but you don't want them to read your secret information, for example, TLS secrets, API keys, that type of thing. So you can restrict access to that, and everything works as intended. The other thing that this gets you in Tectonic is the ability to do multi-cluster. We're testing this with a bunch of folks right now, is the ability to sync that role-based access control information around between different regions. So say you have a production setup in every Amazon data center, which is actually a decently popular thing to do. And then you can make sure that as you're changing the role-based access control, it's reflected across all of your clusters. This helps security teams feel really good at night when they're going to sleep, as well as making sure that you can onboard a team into all of your production environments, for example, with one click. So we'll dig in a little bit more in the demo for this, but what the role-based access control encompasses in Kubernetes is having cluster roles. These are things that everybody on the cluster should be able to have. These are typically like admin type roles for your infrastructure owner. And then you have a cluster role binding, which binds users to those roles. So in an LDAP group, you would bind, say, the LDAP query for engineering management to have access to the entire cluster, for example, that type of thing. And then you can do the same thing per namespace. There's also service accounts, which are like what you would typically think of as like an API key, and you can say this service account has access to update this very specific type of deployment in my cluster, and you can hook that up to a CI system that can be revoked, audited, etc. And we provide a really great management interface for this, which we'll check in the demo. For developers and engineers, Tectonic really gets you a lot of great standardization. So depending on what you want to do, if you're on application team A or B, you have all this standardized authentication for both users accessing those systems as well as service accounts and robots, software orchestrating your cluster for CI systems. And it's really nice for your IT team to set up those permissions, and then everybody gets to use that configuration to interact with the cluster. So if you have engineers that are being onboarded and just joined the company, it's very easy. Everybody can tell you how to use the cluster because it's very standardized, as well as if you're switching teams, the same type of thing. And that goes for monitoring as well. So the cluster has built-in monitoring for your infrastructure owners to keep track of everything, as well as for applications running on top can access those same cluster services to start exporting metrics and alerting on them. And that can be the same across application A and application B. And this is where folks like Concur and Ticketmaster have seen that standardization really get them accelerated to deploying applications, focusing on new features instead of fighting with a bunch of scripting and that type of thing. Here's another screenshot of some of the built-in monitoring, so you can check out exactly how much resources your containers are using. And then you get some of the benefits of Kubernetes. This is showing a deployment for my website, and you can see that you can do rolling updates, and we'll take a look at that in a second. And we talked about application services and the standardization. One of the really exciting things that Tectonic has built in is cloud services for running etcd and Prometheus. These are foundational elements to running kind of container native infrastructure. And what this allows you to do is run a complicated distributed system, but controlled in software. So you're not running manual commands to set up a clustered etcd environment, for example. We have software running in Kubernetes to do that for you. Same with Prometheus. If you have an engineering team that needs to set up a monitoring stack, that's a one-click operation, and you say, hey, I want a HA Prometheus set up, and I want you to keep it updated for me. And then you can expose that to the engineering teams. And the great thing about running this software is that if you're running one Prometheus or 30 Prometheuses, it is not any harder for you as the admin to run that stuff because the software is actually running it for you. Here's a little bit more about what each of these do. So you get all the power of Kubernetes built into doing scaling and backups and failover of these pieces of software, as well as using all the primitives for RBAC and label queries, that type of stuff that we'll dig into in a sec. And I mentioned monitoring dashboards. This is what that looks like. So we have things that are kind of active health checking for the cluster, as well as doing longer term capacity planning, and then a bunch of pre-configured alerts for any failures you may have in parts of the cluster and how to recover those. All right, let's jump over to the demo, and then we can come back and do a little summary. All right, so this is what the kind of initial screen looks like in Tectonic when you log in. This is our cluster overview. You can see that we've got a good sense of what the cluster health is doing, whether the control plane is healthy, and then some of our capacity planning metrics. You can see I've got an alert firing here, which we'll dig into in a second. The first thing I wanted to cover is how this Kubernetes cluster is set up, and so I want to take a peek into kubesystem. This is the namespace that runs all the Kubernetes components, and I want to highlight something that Tectonic does, which is really unique, and this is what powers our automated operations, and this is self-hosting Kubernetes components. So Kubernetes has a scheduler, for example. This is what controls where your applications get scheduled to on each node, and we actually run that on Kubernetes. What this means is the same rolling updates and all these role-based access control primitives that you get for your applications running, we can also use to update the system underneath. So this kube scheduler, we've got 3 copies of it running. I have 3 masters in this cluster, And so that's one running on each master, keeping it up to date. If I scaled out the master auto-scaling group, this would increase or decrease accordingly. And this is what gets you that HA environment. Also here in the daemon sets, these are services that run on every node in the cluster, and these provide a lot of kind of deeper primitives. So if you have like a monitoring agent that you need to run on every host, this is where you can do that in one click. As you scale up or down the number of nodes in the cluster, that will change as well. And we're running things like the kube proxy. This is what does some proxying services so that your connectivity works between nodes, as well as things like the API server. Now let's dig into some end user applications, and for that we're going to go look at my website. And so you can see here I've got 2 copies of this running. This is a deployment which just says stamp out X number of these, and you can see that we've got our update strategy is rolling update, so that means do a clean rolling update of this service. If I change it from version A to version B, you can set the number of max unavailable pods, how many you can surge over the allocated amount. And the real takeaway here is that this used to be things that you scripted up. You either had a janky bash script to do this, or you might even have done this manually, someone just sitting there waiting for caches to clear and that type of thing. Whereas here the system and the software is doing it for you, and this is where you start reducing that technical debt. So if we wanted to boot a new one of these really quick, we'll just increase it from 2 to 3. So our desired count is now 3. And then now you can see that we have 3 available, and that is how quick it takes to increase capacity. Kubernetes also has primitives in here for doing that automatically via pod autoscalers. So those are basic Kubernetes primitives, but I want to talk about some things that Tectonic sets up for you by default, and that is Kubernetes ingress. And what this is primarily targeting HTTP workloads and being able to do routing to services based on host headers and paths and ports and that type of stuff. And what you can see here is I have some of the websites that I'm running on this cluster, and matching that host header, it actually will route to a Kubernetes service behind the scenes. And this is all set up by default, running through an ELB with the Tectonic installer. And what this gets you is just 0 to up and running and exposing an API endpoint or a web endpoint, whatever it is, just by default. And this used to be, once again, something that you might have had some janky scripts to set up. You might have had something that you actually have to run a CI job to even set different endpoints. So if you need to fail over, the process might be 10 or 15 minutes. Kubernetes is handling the health checking automatically for you. So this is one of those niceties that you get out of the box. And this is also kept up to date through the automated operation. So as there's performance enhancements, new features, things around related to TLS, for example, you can do all of that and get it updated. Speaking of updates, let's go take a spin through what the cluster updates look like. As you can see, I'm running the latest version of Tectonic 175. That is Kubernetes version 175. And you can see that I'm on the pre-production channel. Tectonic has 2 different channels that you can subscribe to, and this is just to limit risk when doing updates. You can keep your pre-production servers on a pre-production channel, have those update first, test any compatibility that you need with your applications there. And we just really suggest that choose the appropriate channel and kind of keep it on automatic, and then you can find some of those any issues before they pop up. And we ship new updates as new versions of Kubernetes come out. That's typically about once a month, and so you can do a one-click rolling update of the entire cluster. And the important part is this is 0 downtime through the HA capabilities of Tectonic. So your end-user applications will never know that the cluster is being updated. This is that perfect separation between infrastructure and applications. We looked at some of the monitoring on the homepage here. You can also dig into the Grafana dashboards for some of these things to get a little bit deeper view. This is the control plane status. So here you can see that we've got all of our request latencies. You can see request rates, the end-to-end scheduling through the system. So as I just scaled out my application, you can see that the scheduling is very, very fast, and you can alert on all these types of things as well. Also available are the built-in cluster alerts for Kubernetes itself. You can see that we've got a bunch of default things for just detecting if disks are running full, if you have a lot of nodes that are in not ready status. This can be for networking blips or running out of file descriptors and that type of thing, as well as different parts of the cluster itself running into issues. Here you can see that one of our API servers is having an issue right now. This could be, a transient networking blip and that type of thing. But as you can notice, the cluster is completely up and doing just okay. And all this monitoring that you're seeing here for the cluster can also be exposed to your applications. This is through the Open Cloud Services. And so I can create a new Prometheus cluster right off the bat here. I can control the version. This is how you can do updates to it, say exactly how much memory it gets to use for maintaining the metrics that are in there, and then click create and it will get created. We talked through the role-based access control. I wanted to show off some of those screens. So here you can see these are the cluster-wide role bindings I was talking about. These are, as you can see, a lot of admin bindings for my user and some other users to admin the cluster, as well as some namespace role bindings. These are permissions specific to a namespace. And then we've got all the built-in Kubernetes primitives that the cluster itself is using and is locked down communication between components. Now, the great thing is if you set up like an LDAP query, for example, and you want to see if it worked, you can also then go impersonate one of these roles and see what it's doing. So let's impersonate this basic user group. As you can see, I'm in this unauthenticated group, and as you can imagine, that doesn't have access to anything. So our monitoring is showing that state as well. You go look at a deployment, restricted access, replica sets, same thing. Most importantly, secrets. And so this is what you can use to isolate control of like a CI environment, or like I said, you've got some contractors that should be only looking at very specific things and not others, as well as letting the engineering team not manipulate parts of the cluster that they shouldn't have access to. And the most important thing about all of this, I'm using our UI to do this, but you also get the exact same experience through kubectl. This is the command line interface that supports all of the RBAC primitives. You can manipulate and scale all of these objects that you're seeing in the UI via the command line. It's a really great experience to jump back and forth between them as our console uses WebSockets, so everything is kind of reflected immediately. And this is just a really great experience for, you're testing out something locally, you're changing some code or config flag or whatever it is, and then have that updated immediately. And switch between clusters and do, roll that out to staging and production. And then that is about the end of my demo. I'm sure you have some questions from that, so we'll get to those in a second. And let's jump back to the deck. So I hope that demo showed you some of the capabilities that you can get out of Tectonic. This is bin packing your infrastructure to reduce cost as well as remove technical lock-in and technical debt on all the kind of glue code that you have to do in a modern CI pipeline to get application code built and running on a server. That time to deployment is really important for scaling up your applications, getting new features out the door, and the most important thing there is that you're actually shipping business value. You're not fighting against your infrastructure. You're actually, shipping this code that we can, either charge more money for or will improve the, performance for our subscribers. Whatever it is that your application does for your business, you're focusing on that instead of fighting with your infrastructure. And then the hybrid cloud and all of the infrastructure installers that we provide help you eliminate cloud provider lock-in, but also nicely tie into those infrastructure platforms where it makes sense. We talked about the auto creation of ELBs and EBS volumes for your applications if they require it. And then simplifying the infrastructure management from deploying the clusters and updating the clusters to auditing the access control and user management that you have so that you can onboard your entire organization onto a set of shared infrastructure. So that is Tectonic, and we'll take some Q&A. There is a 10 free node trial across all of our different platforms. at coreos.com/tectonic if you'd like to check it out. We also have some Vagrant-based sandboxes if you want to try it out locally on your machine as well. Then let's jump into
Awesome, Rob. Yeah, great presentation. And so yeah, we've got a ton of questions here. So I'll start from the top here, and just a reminder to all the attendees, if we don't answer your questions today, we'll follow up with everyone individually by email. We do have quite a number of questions, so we'll try to get through as many as possible. So Rob, I think a theme that I'm seeing here across many of the questions is asking around support for Windows, running CoreOS containers under Windows and running in a mixed environment with Linux and Windows.
Yeah, we are evaluating Windows support as the upstream Kubernetes project supports it. I believe that is in the early stages, and so we're definitely looking at that. That's something we're interested in. Yeah. Don't currently support it today.
Okay, great. Another question here is, how does Tectonic compare to COPS?
I believe the some of the install side things are decently similar. I believe COPS outputs Terraform, or maybe that's, I get Kube admin and COPS confused quite frequently. They have a lot of overlap. But in the end, you're going to get, VPCs and, public-private subnets and the auto-scaling groups. That type of thing is kind of a standard Kubernetes install. And so you get that from both of them. The nice thing about our installer is it does have, Amazon-specific things, as well as the different other platforms that we support, bare metal, VMware, that type of thing. So you get that consistent install against all of those platforms, whereas I believe COPS is Amazon only.
Yeah, and then Rob, would it also be, I think another good point to highlight there is with CoreOS, you have a supported distribution, right? That's supported by, or with Tectonic, that's supported by CoreOS as well.
Yes, absolutely.
Whereas with COPS, you'd be going with an open source solution.
Yep.
Great. Another question here is, do you manage kubelets with FleetCTL when you run Kubernetes on CoreOS?
No. So the Fleet project was, little background, a project that CoreOS did and kind of before Kubernetes was a thing. And so that project has been kind of in self-supported, community-supported mode as we shift resources onto Kubernetes. We think that is the best thing going forward. So yeah, Fleet is not involved in this whatsoever. And this is where the self-hosted nature of Tectonic that I was talking about earlier gets you those same benefits, but all using a Kubernetes API and using the kubelet, that type of thing, just running on the host itself.
Okay, great. Another question was around RBAC and whether that RBAC functionality extends to container registries.
Currently, the RBAC functionality is all based on Kubernetes primitives, and so that does not cover any the container registry functionality other than pull secrets that you use to pull containers from a registry are secrets in the cluster, and so you can write RBAC rules around those as well.
Okay, great. I have another question here asking is it possible to use H2 or gRPC for inter-pod communication?
Yeah, I don't think Kubernetes has any restrictions based on network protocols or anything that you'd like to use talking between two pods on the network. Yeah, they should just, they're Linux processes at the end of the day that are going through a networking stack. Yeah, so there should be no issues there. And I know that gRPC works because a lot of the communication, at least between the Kubernetes control plane and etcd, is over a gRPC interface.
Yeah, and I think an important thing to note is that there's any functionality you have in upstream Kubernetes, Tectonic is just extending that functionality.
Exactly. Yeah, we don't modify the upstream version of Kubernetes whatsoever. We think it's really important, and it's actually really nice that our interests are aligned there. So we have a team of engineers that makes changes and bug fixes, et cetera, to Kubernetes. And we want to get that in the upstream project as quickly as possible, and then we can very quickly consume that into the cluster via our automated operations. So we don't hold anything back. We want it all to get great and upstream.
Okay, excellent. There's a question here on, can Tectonic monitoring show you cAdvisor information?
I believe it could be wired up to do that. I believe that cAdvisor is not the source, or no, maybe it's cAdvisor is the source, but Heapster is not used, I believe. I'd have to follow up on that one, but yeah, it's a generic monitoring platform, so you can hook up any sources that you want that export in the Prometheus format, which almost all of the kind of CNCF related projects, anything container native is supporting Prometheus.
Okay, great. Does Tectonic have an API or a CLI?
It uses the upstream API and CLI. This is part of that unmodified Kubernetes story. So you can use any version of kubectl you like that's built upstream, as well as when you're writing against the Tectonic API, that's really just the Kubernetes API. And this is where we really believe in not locking you in on protocols like that. So we want to support, the open protocol for that as well, and you see that in a lot of our open source efforts in other parts of the system as well.
Okay, great. So we have a newcomer asking a question. As someone who's completely new to this, is there a best practices guide for migrating traditional on-premise environments into the CoreOS Tectonic platform?
There's a lot of great information out there. That would be not a complicated guide, but probably a rather long guide. It's just everyone has different cultural tendencies in terms of how they want to migrate things, as well as the exact setup of their local networking in a colo or that type of thing. So I think that's where those guides get a little bit tough to write. There are a ton of best practices on our website for kind of different parts of that migration, from containerizing your first app to installing the infrastructure, setting up the permissions correctly, doing monitoring, setting yourself up for kind of failover and disaster recovery. So all those are great resources we have on our website. I can't think of like one guide that covers the entire thing though. And I'll add that our support engineers are here to help you. We do a lot of kind of architecture advice with our customers as they're getting their first apps running and then starting to scale out, and onboarding 4 or 5 development teams that are running 20, 30 applications, and all the containers and permissions and auditing that come along with that. We're here to help you be successful.
Great. Okay, we got time for a few more here. There's a question around, is CoreOS installed on EC2?
Yes, these are all using the kind of lowest level infrastructure primitive on each provider, so EC2 on Amazon.
Yep. I think it's also worth mentioning that all of your AMIs are available in the marketplace, so you can actually deploy an EC2 instance that already has CoreOS installed for you.
Yep, yeah, we build all those programmatically, and I mean at this point, Container Linux is shipped about every month, and we have 3 different channels of it. So we've probably produced hundreds of AMIs over the years. So we've been doing this for a while.
Okay, great. See a couple more here. Are there any plans to integrate Tectonic installer with Foreman rather than just Terraform?
No plans for that. At the moment, we see Terraform as kind of our opinionated and best kind of technical solution for this. Yeah, we're 100% behind Terraform and a lot of the cross-platform support for it and all that type of stuff. So our tooling is definitely supported and tested with Terraform.
Great. There's also a question here on whether there's a preference for a physical or virtual host.
No preference. We actually, I would say almost all of our larger enterprise customers are running on both a cloud and bare metal. And so we equally support both of those. And that can be VMs running on bare metal or VMs running on Amazon. But Pixie booting directly on a bare metal host is a very, very popular thing to do, and you get all the benefits of Tectonic across both of those platforms, and so to us they're equally supported, equally important, and we have customers using both.
Excellent. Looks like we have time for one more. And there's a question on how many different applications do you typically run inside each pod, or is it typically one app per pod?
It's typically one app per pod, but that doesn't mean that there's only one component in there. So like a common thing you might do, for example, is you would have one container that is your actual application, and then you might have either like a cache preloading application that will, when this thing boots up, it might preload a bunch of files, or if you need to charge a database or something like that. You can do that, and you can not report that the pod is up and running yet until that happens. So Kubernetes is smart enough to not start sending traffic to that until the pod reports healthy. So that's kind of a use case on startup. And then you might have different kind of what they call sidecars for doing things like log exporting. So if you've got like a Splunk log exporter, or you're using any of the open source tools to do this, you can run that alongside your container. And have it, you can share volumes between containers in a pod. You can have local host networking. So all these things make it very easy to run more than one thing in a pod. But then also, like, a very typical use case is just to run a single web server or a single Go binary or something like that in a container as well.
Okay, great. So we're going to go ahead and wrap up today's webinar. Just as a quick reminder, you'll receive an email in the next couple of days with a link to the slides on SlideShare and a recording of today's webinar. I just want to thank all of the attendees for attending, and if you have any questions, please don't hesitate to reach out. Thank you very much.
Yeah, thank you all for joining, and check out coreos.com/tectonic for the 10 free nodes, as well as the sandbox for doing a local POC. Thank you all.
Thank you.